Genetic studies have been very successful at identifying genetic loci that are associated with an increased risk of breast cancer. One of the main questions is whether these genetic loci can be used in the clinical setting. What seems quite clear is that on their own, genetic factors have too small an effect on risk to be useful, but together they may be more useful. So for example, in breast cancer, we know at least 13 loci that are associated with risk. And using information from 13 loci, you can identify women at low risk, women at medium risk, and women at high risk. And by combining that sort of information, it would be possible to offer women personalised screening programs using X-ray mammography based on their genetic risk. And therefore you can target screening at women at highest risk of disease who are most likely to benefit from the screening mammography.
Grâce aux échantillons de sang collectés des années avant l'apparition, la survenue des cancers du sein et de l'endomètre, nous avons pu mettre en évidence un lien entre des niveaux élevés, mais toujours à l'intérieur de la normalité, de différents estrogènes et androgènes et un risque significativement augmenté de développer un cancer du sein après la ménopause ou de développer un cancer de l'endomètre. Ces résultats nous aident maintenant à étudier mieux les processus biologiques qui précèdent l'apparition et le développement du cancer du sein. Et de nouveau, c'est seulement la nature prospective de cette étude qui a permis d'étudier avec une connaissance claire de la séquence temporelle les niveaux hormonaux et le risque de cancer du sein.
BRCA1 and 2 mutations in relation to breast and ovarian cancer. These are genetic risk factors that carry a substantial high risk of development of disease, irrespective of a person's exposure to other factors. But in general, genetic factors are less strong and work in conjunction with environmental exposures.
L'EPIC a montré une relation entre le fait de vivre dans des quartiers plus hautement pollués par rapport à vivre dans des quartiers moins pollués et l'apparition d'un cancer du poumon. Nous avons fait cette étude en faisant un lien entre l'histoire d'adresse des individus et 30 ans de données enregistrées dans différentes villes européennes sur les niveaux de pollution. Tout ça a été fait avec l'OMS, le Bureau européen de l'OMS, qui garde 30 ans de registration. Et la distance en mètres et en centaines de mètres des principaux axes routiers est un indicateur du risque de développer un cancer du poumon, même chez les non-fumeurs. Évidemment, il ne faut pas tout mélanger. Le tabac multiplie par 60 fois le risque de développer un cancer du poumon dans EPIC et la pollution atmosphérique augmente de 1,4 fois le risque d'un cancer du poumon, mais au niveau d'une population, c'est un problème de santé publique.
In the UK, we were able to use cohort methodology to analyse national rates of incidence and mortality from breast cancer to show that the screening programme in the UK is delivering a 20 to 30% reduction in deaths from breast cancer. Similarly, in Sweden, we used cohort methods and found an even larger reduction. We have been working with Zoe Uli and Rosemary Ansel Park at INVS in Paris, and we've been using different methodologies because there are different data available in France. And again, we have found a 20 to 30% reduction in mortality from breast cancer as a result of screening here in France.
If you're at low risk, you might not need mammograms until you're in your 50s or even 60s, whereas if you're at high risk because of your genetic profile, it may be sensible to start mammograms at the age of 40. Because of the risk of disease being higher. When should you offer the genetic testing? Of course, it would be possible to offer genetic testing at a very early age because your genes aren't going to change through life. And as we know more, it may be that the population choose to have a genetic test at the age of 20 or 30, long before they're at risk of disease, but then that tells them something about when they should start prevention programs. And this would be true for breast cancer, but also for other cancers. You may have prevention programs for prostate cancer, where you have a test in your 30s, and it tells you whether or not you should start screening at the age of 60.
In women aged 50 and over, who are the main target of these screening programs in both countries, there's not a major difference between screening every 2 years and screening every 3 years, because the tumours, put simply, the tumours tend to grow rather slowly. If we were screening women aged 40 to 49, for example, you would see a difference because the tumours grow faster then, and you would see a better result with a 2-yearly screening.
One of the possible advantages of targeting a program at people at highest risk is that your program becomes more efficient, because instead of spending the money on everybody, you're only spending on those at highest risk who are going to benefit most. So there is the opportunity for improving program efficiencies and reducing their costs, as well as improving the effectiveness because of the targeting.
It's probably not possible to advise countries with a 2-year interval to change to 3 years, because the one thing we have learned in the UK is that if you have a 3-year interval, sometimes it drifts out to more than 3 for one organisational reason or another. And secondly, at 3 years, you don't have much of what we would call a safety net. If you miss a cancer at screening, it's probably going to arise in the interval before the next screen. Whereas with 2 years, if you miss a cancer, you've got a good chance it will still be there and asymptomatic at the next screen.
Avec ce type d'études qui sont très ouvertes par leur nature, on trouve parfois des résultats qu'on ne s'attendait pas. Par exemple, nous avons trouvé un léger effet apparemment protecteur de l'obésité par rapport à la survenue du cancer du sein avant l'âge de 45 ans. Le même résultat a été trouvé dans plusieurs études cohortes en Amérique du Nord, a été retenu au départ paradoxal, parce qu'il n'y a aucune raison de penser qu'être un excès de poids puisse réduire le risque de cancer du sein entre 30 et 40 ans, pour ainsi dire. Mais notre étude, comme nous avons, avec les échantillons de sang, pu mesurer des marqueurs de syndrome métabolique, nous a permis de voir paradoxalement que certains marqueurs du syndrome métabolique, particulièrement les peptides C, sont aussi associés avec une apparente réduction de risque de cancer du sein. On parle d'un effet minime, c'est 10 à 15% de réduction de risque.
In Canada, we're at the point of having launched a large study across the country with 300,000 participants eventually being included. We're in the first year presently. One of the key features in this regard of the Canadian study is that we recognize the need to integrate the study of both societal factors, but also genetic and molecular factors to help improve our understanding of features. And as we all know, with obesity as an example, trying to build our communities differently and improve how people can live within their communities will actually help us stem that tide. Canadian population is very interesting, culturally and ethnically quite diverse. This adds a lot to the excitement of being a Canadian, the interesting mix of how our communities are made up and how people live. And indeed that diversity is one of the key reasons why it's important for us to launch a study of this type in Canada, because worldwide maybe the other studies would not actually be quite as relevant.
Les avancées dans les connaissances des causes du cancer rarement viennent d'un seul type d'étude ou d'une seule approche. Donc l'épidémiologie contribue en mettant en évidence des liens entre mode de vie, environnement, facteurs métaboliques et risque de cancer. Donc c'est cette globalité de l'approche scientifique que fait finalement avancer nos connaissances et avancer aussi les possibilités de prévention et de traitement des cancers.